Okay, so this is going to be the second video in the OpenRocket tutorial series for the OPHS rocket class. So I do not believe that I covered stability in the last lesson, so I'm going to go ahead and talk about that. So in our upper right corner, we can see that we have a stability margin of 2.57 calibers. The center of the stability is determined by the distance between the center of pressure and the center of gravity. And I like this number to be above 1 at least. For Tark rockets, I have kept it usually between 1 and 2. You don't want it overstable, and you certainly do not want it understable. So that stability margin is going to be with a motor in it. So right now, this is the stability without a motor. If we go to our flight configuration, and if I add a new configuration, say I type in an F32, click it, it will automatically input that into our stability, and we can see that we have a stability margin of 2 calibers. So we are good there. Um, in order to make your rocket more accurate to what it is in real life, I previously stated that you should weigh all your components. In addition to that, you should go into the Sustainer tab, double click on that, and if your mass is still off, you can override that mass to what it is in your on your scale. So say that is 500 grams, I can input that in 500 grams. Now this will mess with your stability margin. You can also override the coefficient of drag. What this is going to do is change the drag characteristics for the whole rocket. So I will get into that later once I start to sim some motors and get altitudes. I'm going to go ahead and click OK. As you can see, the mass has now been overridden to 500 grams. If you want to turn this off, just uncheck that override mass. Now that we have this, I'm going to go into our Motors and Configuration tab. When you are starting off, make sure to look at the TARC approved motors list as well as what is in stock. The further you get into the season, the less motors that are going to be available, so make sure to fly early, test early, buy early. So you're going to go ahead and click New Configuration, and you are going to type in whatever motor you want. In this new version of OpenRocket, you can change to look at motors which are not in regular production. So if I click that, it will significantly limit the amount of motors that we have. So a motor that I know has multiple is the F23. So you can see that there are 2 in here, but if I uncheck this box, it will give us 3. So make sure to click that one to know which ones are currently being made. I believe it is this one that we usually use, so I'm going to go ahead and click that, and it inputs that motor into here. Now the stability will change based on what type of motor you are using, because depending on the motor, the average center of gravity will either shift forward or backwards, and that varies depending on the weight of the motor and the length of it. So I have 2 motors in here. So I'm going to go ahead and go into flight simulations, and it is going to give me automatically the 2 flights from the motors and configuration tab. Now there's a little warning here, you do want to be aware of that. It says recovery device deployment at high speeds. You want to try and limit that deployment speed. That deployment speed should be around 25 feet per second at the max. The faster you go, the more likely you are for the rocket to zipper. So we can see that warning, and usually that's due to the delay. So this dash right here, and that number signifies the amount of seconds after burn time for the motor ejection charge to go off, which will pop out that parachute. So you can see that there's an optimum delay here of 6.37 seconds. However, if we go ahead and look up the F32, and we go to Aerotech site, you'll see that it comes in a 6 second. It also comes in an 8-second and a 4-second. There are no 0.32 seconds. So try to do the best you can trying to find the motor with the best delay. That would be the 6-second delay. So we can go ahead and create a new motor, and instead of using that 4-second delay, we can change it. In order to do that, we're going to click on the motor. We're going to go to this ejection charge delay, and we are going to delete that and set it to 6. Click OK, and we can go back into the flight sim, and it will give us a new flight. Now this velocity off the rod is important because we do not want the rocket going too slow off the rod. If it's going too slow, you are not going to have a good time. 45.8 seconds is feet per second is probably towards the slower end. I try to get it a little faster depending on if it's really windy out, but that should be fine. If you notice that these numbers are very slow, you're going to want to go into the Edit Simulation tab and change the launch rod length. So if you measure that 1010 aluminum rail, which is sitting in the back of the rocket room, it is 8 feet, I believe. However, there's a wire which your rocket will catch, so that may limit it to 7.5 feet. The launch site, if you look here, also is important. You want to change this to the latitude, longitude, and altitude of Underwood Farms. I believe this should be about right, so if you want to copy that, you are welcome to. Please note that if you are flying in the desert or any other launch site, then the latitude, longitude, and altitude of that launch site will be different. Your 3 big factors that you are going to have to deal with is going to be your wind speed, your temperature, and your pressure. When you are out on the field, I would recommend bringing a computer and measuring the wind speed right before you're going to launch because it varies throughout the day, as well as the temperature and the pressure. The temperature and the pressure will change throughout the day. In the new version of OpenRocket 24.12, you can change your wind speed to be multi-level. Now this is kind of a perk. So you can add a altitude and the wind speed at said altitude. Now you may be asking, how would I know the wind speed 300 feet up? Well, there is a website. You can go to windy.com. More park. If we scroll into more park and we go to trying to find Underwood. Should be around here somewhere. Anyways, so you find more park. Click a dot right there. It will automatically put this into knots. That is the wind speed. That's a unit to measure wind speed. You can change that to miles per hour. You can also just convert your knots. If you go to this altitude button right here, it automatically calculates it at surface level, but you can change it from 100 to 330 to 2000. So it gives you a little bit of room if you want to mess with that setting right here. But I think the average should be just fine. I'm going to go ahead and click OK. And we are good over here. Now automatically, I believe OpenRocket sets your launch rod length to 3 feet. So your sims will be way off if your launch rod is at 3 feet. So please do change that. Ground hit velocity is determined by the size of your parachutes. So the harder you hit, the more likely you are to break a fin off or crumple the body tube. So you want to limit that, but you also want to keep it within the parameters of TARC. So I'm going to talk about now CD backtracking. So that is where you can perfect each flight after you've done it to try and find the true coefficient of drag of your rocket. So if you go to Tools and Component Analysis, Drag Characteristics, it will give you this total coefficient of drag value right here. And it will automatically calculate that for you, but it might not be what it is in reality. So to find that, I would go back to your flight simulations. You should have a log. We can change our simulation right here, and I would change all of this data after the fact to what you recorded in your flight log. You can also change this on the go to determine what future motors you're going to use. And once you get that, say your apogee is still off. Say you hit 800 feet instead of 1,037 feet. I'm going to delete these for now. I'm going to go up to that sustainer tab and I am going to hit override coefficient of drag. If you do not click override for all subcomponents, it will only add on a coefficient of drag value to the sustainer. It will not change it for the whole rocket. In order to change it for that whole rocket, we are going to click override for all subcomponents. Say we want to hit that 800 value and we are at 1,000 something. I'm just going to start off with a 0.75 value. If I resim it, I am hitting 848 feet. So that's giving you more in a ballpark. You can hone that in until you get what you hit in your actual flight log. But that is important, and instead of averaging out every single simulation based on weather data, I would input each individual weather data so that way it's more accurate. If you do not do that, then your coefficient of drag value would be an average of all the flights rather than what it is per flight. This number doesn't change depending on the flight, but your weather conditions do change. And if you average out your weather conditions, then your coefficient of drag value will be different. So that is pretty much it to overrides of coefficient of drag. The other option you have is to change the component finish of each part. If I go into the nose cone and I go into component finish, you can change rough, rough unfinished, all of these for the surface of your rocket. Now, it doesn't necessarily matter for the inside parts, but the outside parts do matter because that is what's going to receive airflow. So instead of overriding the whole rocket, you can just change the component finish for each part, but that is up to you. Other than that, that is going to be it for simulations. If there is variability and you are still getting problems with observed apogees, regardless of if you have a backtracked coefficient of drag value, I would make sure that you have multiple test flights and you can consistently hit each value or in a ballpark of the flight before you jump to the conclusion that, oh, one motor is very off. The other option you have is to contact the developers directly. There is a Discord with the OpenRocket developers on it. If you have questions, you can ask it there. Another helpful resource is the Rocketry Forum. So that is about it for rocket simulations.